Hi everyone, this is Mr. Davis. I thought I'd give you a little bit of help with this task here, which is a very important one, which is electron structure of the atoms, the first 20 elements. And this, I'm going to draw my electrons as little dots. You sometimes see them drawn as crosses. They're neither dots nor crosses in real life, but that's another lesson. The thing you have to know is you have to know the proton number of each of the atoms, the atomic number, because that tells you how many protons there are. And in a normal neutral atom, that happens to be the same as the number of electrons. So hydrogen's proton number 1, and so it's got 1 electron in its outer shell. There it is. Helium, proton number 2, which has got 1 and then 2 electrons orbiting. Now, when we go on to lithium, we've got 3. So we've got 1, 2, but that shell now is full. So the third one has to go into the next shell up. Okay, on to beryllium. 1, 2, here's our third one, and here's our fourth one. Okay, boron's got a proton number of 5, so it's 1, 2, 3, 4, 5. There you go. And then carbon's got a proton number of 6. 1, 2, 3, 4, 5, 6. Okay, when we got to nitrogen's got a proton number of 7. 1, 2, 3, 4, 5, 6. I find it's better to just double them up, to pair them up, because it makes it easier to count. So here's our 7th one there. Okay, oxygen has got a proton number of 8, so it's got 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. There you go. On to fluorine. Fluorine is 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There you go. Neon's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when we get onto sodium, this one's already been done for us. We can see that actually the sodium has 11 electrons, and so we do the first 10, but the 11th one has to go in that shell there, the next shell up. That's why we're starting a new period, because we're now filling a new shell. Okay, so this period is for the first shell. This period is when we fill the first, but now we're filling the second. This one, the first and the second are filled, and now we're filling the third. So magnesium's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. Aluminium, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to go faster now. This is the advantage of pairing them up. You make less mistakes. Silicon has got 4 electrons left in its outer shell. Phosphorus. There's our first 10 in the first 2 shells. And then we've got 1, 2, 3, 4, 5 to find a home for. Okay, now we're on to sulfur. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's chlorine. And then finally, on this column here, we've got argon. Here is the first 10 electrons, and then 11, 12, 13, 14, 15, 16, 17, 18 electrons for argon. Some of you might have started to notice, actually, look, the shells on the outside are the same, aren't they? 6 on the outside, 5 on the outside, 4 on the outside, 7 on the outside, 10 on the outside. There seems to be a little bit of a pattern forming here. More about that in later lessons. And finally, we will do this. The inner shells now are all looking identical. And so I can go very quick without even counting. Okay, so I'm up to 18, 19. That's the number of protons for potassium. And then my final one is calcium. I'm finding a home for 20 electrons. The first 18, I know exactly where they go because I've drawn it out so many times now. And then finally that one. There you go. Okay, that's how you fill the shells.